Hey guys, tonight we're going on a journey, a quiet expedition not across a distant sea or through an ancient forest, but into the very heart of our cosmic neighborhood. I want you to imagine for just a moment that we are drifting gently in the vast, silent blackness of space. The only light comes from a single immense star, a brilliant beacon of yellow and white that warms our faces even from this impossible distance. This isn't a thrilling high-speed adventure, but a slow contemplative drift. A chance to simply observe, to listen, and to feel the quiet rhythm of the universe. Of course, a quick reality check for our journey: if you were actually out here unprotected and alone, you would freeze solid or be vaporized in a moment, your blood boiling in the vacuum. It's a harsh reminder of how fragile we are and how precious the conditions are back home. So, before you get comfortable, take a moment to like the video and subscribe, but only if you genuinely enjoy what I do here. And as you settle in, let me know, where are you in the world right now? What time is it for you in this very moment? Let the world outside your window fade away, and let's begin our slow, gentle descent into the story of our home. The sun, that magnificent burning orb that governs our everyday, is not just a source of light and warmth. It is the beginning of everything we know. Imagine it not as a distant object, but as a great living furnace at the center of our family of planets. For us here on Earth, it is a constant, reassuring presence, the very metronome of our lives, dictating the rise and fall of the tides, the changing of the seasons, and the cycles of growth and rest. But its quiet appearance belies an unimaginable and chaotic power. The sun is a star, a colossal ball of plasma held together by its own gravity, engaged in a furious and eternal dance of nuclear fusion. Deep within its core, where pressures are so immense they defy our everyday understanding, hydrogen atoms are crushed together to form helium. This process, this incredible alchemical transformation, releases a staggering amount of energy. The energy doesn't just burst forth, it travels outward in a slow, arduous journey. A single photon, a tiny particle of light born in the sun's core, can take hundreds of thousands of years just to reach the surface. It bounces and ricochets through the dense plasma like a pinball in an endless machine, before finally escaping into the cold vacuum of space, beginning its 8-minute dash to Earth. This journey of light is a profound and humbling thought. The sunlight you feel on your skin, the light that allows you to see the world, began its life in the sun's core centuries ago. It's a message from the deep past, a tiny ancient messenger. And yet, this is not a one-way street. The sun's influence extends far beyond mere light. It constantly exhales a breath of charged particles known as the solar wind. This wind, a stream of electrons and protons, rushes outward, interacting with everything it encounters. Here on Earth, it collides with our protective magnetic field, our shield, which deflects most of it. But sometimes when the wind is particularly strong, it can pierce through, creating the stunning celestial light show we call the aurora borealis and aurora australis, the northern and southern lights. It's a reminder that even our seemingly tranquil planet is a living, breathing entity, constantly interacting with the larger cosmos. We are not a passive audience. We are part of this grand cosmic play. The sheer scale of the sun is a difficult thing to grasp. If you were to hollow it out, you could fit over 1 million Earths inside. Its mass accounts for more than 99.8% of the entire solar system. Everything else, the planets, the moons, the asteroids, the comets, is just a tiny, insignificant bit of cosmic dust orbiting this one magnificent star. This gravitational dominance is a powerful metaphor for our own lives. There is often a central powerful force around which all our smaller concerns and daily activities revolve, something that provides the energy and the rhythm for our existence. For the planets, it is the sun, a silent, unmoving anchor in the cosmic ocean. And it is this very gravity that keeps us all in a delicate and precise ballet. Without it, the planets would simply fly off into the abyss, lost and alone. The sun's gravity is like an invisible string, constantly pulling, constantly guiding, ensuring that every member of the solar system stays in its proper place. But the sun's life is not eternal, and this is perhaps one of the most profound and sobering thoughts in all of science. Stars are not unchanging beacons. They are born, they live, and they die. Our sun is a middle-aged star, a G-type main sequence star, or a yellow dwarf. It has been shining steadily for about 4.6 billion years, and it will continue to do so for another 5 billion years. Eventually, it will run out of hydrogen fuel in its core. When that happens, the delicate balance between gravity and the outward pressure from nuclear fusion will be broken. The core will begin to contract, and the outer layers of the sun will swell dramatically. It will become a red giant, growing so large that it will likely engulf Mercury, Venus, and perhaps even Earth. This isn't a sudden violent event, but a slow, inevitable transformation. In the distant future, the very source of our life will become its undoing. But don't worry, that is a long, long time from now, a period of time so vast it is almost meaningless to us now. The end of the sun is a cosmic tragedy we will never witness. The sun's surface is a turbulent, roiling sea of plasma. Its surface, the photosphere, is a place of incredible activity. Darker, cooler spots called sunspots appear and disappear, governed by the sun's powerful and complex magnetic fields. These sunspots are often the sites of immense eruptions of energy, known as solar flares, and coronal mass ejections, CMEs. These events are like the sun sneezing or perhaps sighing with a burst of energy. A solar flare is a sudden burst of radiation, while a CME is a massive burst of solar wind and magnetic fields. When these events are aimed at Earth, they can cause temporary disruptions to our satellites, power grids, and communications. It's a powerful reminder that our connection to the sun is not always gentle. It is a relationship of both nurture and quiet unseen danger. A fascinating and often overlooked aspect of the sun is the fact that its core is not rotating at the same rate as its surface. Scientists have discovered that the core rotates much faster than the outer layers, a phenomenon that is still not fully understood. It's as if the sun were a great cosmic onion, with different layers moving at their own pace, each part a piece of a larger mysterious puzzle. This raises an interesting question. Is the sun's core and surface a unified whole, or are they two separate entities, bound by gravity, but moving to their own internal rhythms? The truth is, we don't really know for sure what drives this differential rotation, but it's a testament to the fact that even the most familiar object in our sky holds profound secrets. The sun. Our home star is a universe unto itself, a place of immense beauty, incredible power, and deep, quiet mysteries. The light we see from the sun is only a small part of the story. The sun also emits a vast spectrum of light, from radio waves to X-rays and gamma rays. We are shielded from most of the dangerous high-energy radiation by Earth's atmosphere, which acts like another protective blanket. The atmosphere is like a cosmic filter, allowing the gentle, life-giving visible light to pass through, while deflecting the more energetic and harmful radiation. It is a perfect, almost miraculous system of protection. Without it, life as we know it would not be possible. And what a fragile, intricate balance it is. The thin blue line of our atmosphere is all that separates us from the emptiness of space. But even the most stable of systems has its quirks. A truly bizarre and lesser-known fact about the sun is something called the faint young sun paradox. Billions of years ago, when the Earth was young and life was just beginning to stir, the sun was about 30% dimmer than it is today. Based on our current models, a dimmer sun should have meant that Earth would be a frozen, uninhabitable wasteland, completely covered in ice. Yet geological evidence shows that there was liquid water on Earth's surface during this time. This presents a massive puzzle. How could a dimmer sun provide enough warmth to keep the oceans from freezing? Scientists have proposed various theories from a denser atmosphere with more greenhouse gases to a lower planetary albedo, meaning the Earth would have absorbed more of the sunlight it did receive. The paradox remains a profound and unresolved question, a quiet whisper from deep time reminding us that our understanding of even the most fundamental relationships in the universe is incomplete. So as we drift silently, watching the sun burn a gentle and beautiful, but also violent and mysterious furnace, we can begin to appreciate its role, not just as a source of energy, but as the great conductor of a cosmic orchestra. Each planet, including our own, plays its part in this silent symphony, a dance governed by gravity and fueled by light. The sun is the heart, and the planets are the blood vessels, each one a unique and complex world, a separate chapter in a single flowing story. We begin our journey here with the source of it all, because every story needs a beginning, and in our solar system, the story of everything begins with a star. From the sun, our great quiet heart, we now turn our gaze inward to the very first child of this cosmic family. We are drifting closer now to a world of extremes, a tiny scorched sphere that dances a frantic lonely waltz with its parent star. This is Mercury, a planet of brutal contradictions, a world that is both a sun-baked desert and a place of deep freezing shadow. As we approach, imagine the silent landscape unfolding beneath us. It's a patchwork of ancient craters, a surface not unlike our own moon, but with a different story etched into its face. This is a story of heat and cold, of speed and stillness. Mercury is the swiftest of all the planets. It completes its orbit around the sun in just 88 Earth days. Its name comes from the Roman messenger god, and it's a fitting title for this planet is a blur of motion, a tiny speeding point of light in the vast cosmic dark. This incredible speed is a direct consequence of its proximity to the sun. According to Kepler's laws of planetary motion, the closer a planet is to its star, the faster it must move to avoid being pulled into its fiery embrace. It's a beautiful, but precarious equilibrium. But while its journey around the sun is quick, its rotation on its own axis is incredibly slow. A single day on Mercury, from one sunrise to the next, lasts for about 176 Earth days. This bizarre rotational resonance, where its orbit and rotation are linked, means that for a long, long time, one side of the planet is baked under the relentless glare of the sun, while the other side is plunged into the bitter cold of space. This slow rotation leads to the most extreme temperature swings in our entire solar system. The side of Mercury facing the sun can reach temperatures of over 800 degrees Fahrenheit, 430 degrees Celsius, hot enough to melt lead. But on the night side, or in the shadowed craters where sunlight never touches, temperatures can plummet to a frigid minus 290 degrees Fahrenheit, minus 180 degrees Celsius. This is not a planet of twilight or gentle seasons. It is a world of absolute extremes. And it is this very stillness, this long, slow day and night, that creates one of the most surprising and counterintuitive truths about this scorched world. Despite the blistering heat, there is ice on Mercury. Hidden away in the permanently shadowed craters near its north and south poles, where the sun's rays can never reach, are reservoirs of water ice. These are places of eternal darkness, cold traps where ice from comets and other icy bodies has accumulated over billions of years, remaining frozen in a world of fire. It's a profound thought, life's most essential ingredient, locked away in the shadows of the sun's closest neighbor. The surface of Mercury is a testament to its long and violent history. It is pockmarked with craters, a silent chronicle of the countless impacts it has endured since the formation of the solar system. Without a thick atmosphere to protect it, every piece of cosmic debris from tiny dust grains to massive asteroids has left its mark. But there is a feature on Mercury that sets it apart from our moon: immense cliffs called rupes or scarps that snake across the planet's surface for hundreds of kilometers. These are not caused by impacts. Instead, they are believed to be the result of the entire planet shrinking as its iron core cooled and contracted over billions of years. As the core shrank, the crust wrinkled and buckled, forming these majestic wrinkled features. It's as if Mercury is a great cosmic prune, slowly shriveling in the quiet cold of space, a silent record of its own internal evolution. Mercury also possesses a magnetic field, a curious and fascinating fact for such a small, slow-spinning world. For a long time, scientists believed that a planet needed to have a molten core and a rapid rotation to generate a magnetic field through a process called the dynamo effect. Earth's magnetic field is generated this way, but Mercury, despite its slow spin and small size, has a weak but still very real magnetic field. This field, though only about 1% as strong as Earth's, is an enduring mystery. It suggests that Mercury's iron core is still at least partially molten and that the mechanisms for generating a magnetic field might be more complex than we previously thought. This raises an interesting question. Is the internal structure of Mercury fundamentally different from our models? Or is there another undiscovered process at work? The truth is, we don't really know for sure. And this small, unassuming planet continues to challenge our most basic assumptions about how worlds work. Another strange feature of Mercury is its almost non-existent atmosphere or exosphere. It is so thin that it is often referred to as a vacuum, with a tiny trace of gas particles. This exosphere is not stable like Earth's atmosphere. It is constantly being replenished by solar wind and atoms blasted off the surface by meteoroid impacts. Sodium, potassium, and calcium atoms are the main ingredients, a thin, ghostly veil that is constantly being stripped away by the solar wind only to be replaced. It is a fleeting, ephemeral thing, a testament to the brutal, relentless pressure of the sun. Mercury's surface also has unique geological features known as hollows. These are strange, shallow, irregularly shaped depressions with bright interiors, and they are still a profound mystery to planetary scientists. The leading theory is that they are formed by a process called sublimation, where a volatile material beneath the surface, like sulfur or other compounds, is heated by the sun and turns directly into gas, leaving the hollows behind. But their precise formation and composition are still being debated. These hollows are like quiet scars, mysterious imprints of an unknown process, a silent question mark left on the planet's face. The very orbit of Mercury is not a perfect circle, but an ellipse, and this has a profound effect on its appearance from our perspective. The fact that Mercury's orbit precesses, or shifts, very slightly over time was a long-standing puzzle in physics. The shift was tiny, just a fraction of a degree per century, but it could not be explained by Newtonian mechanics alone. It was one of the first and most powerful pieces of evidence for Albert Einstein's theory of general relativity. Einstein's theory, which describes gravity not as a force but as a curvature of spacetime, perfectly predicted the subtle shift in Mercury's orbit. This tiny, lonely planet, in its quiet, consistent dance around the sun, provided a key piece of the puzzle that reshaped our understanding of the universe. It's a powerful reminder that sometimes the smallest details can reveal the biggest truths. The story of Mercury is one of extremes of light and shadow, of speed and stillness. It is a world that seems almost defined by its relationship with the sun, a planet forever in its powerful, dangerous embrace. Its desolate surface, its strange rotation, its hidden ice, and its mysterious magnetic field all speak to a past of quiet violence and a present of delicate, eternal balance. It is a place of profound solitude, a first stop on our journey, and a reminder that even the closest worlds to us hold secrets that we are only just beginning to uncover. We see it as a scorched, barren rock, but it is a complex living entity, a world with a story as intricate and mysterious as our own. And so we drift away, leaving this world of quiet contradictions behind, and turn our attention to the next jewel in our cosmic necklace. We leave the sun-scorched solitude of Mercury behind our silent vessel, now turning its gaze toward the second planet from our star. Imagine a world veiled in perpetual twilight, a place where the sun is a mere ghost in the sky. its light filtered through a thick, suffocating blanket of clouds. This is Venus, our sister planet, a world that once held the promise of being a twin to Earth, but which followed a very different and tragic path. From a distance, it is a magnificent glowing marble of white and pale yellow, a beacon of serene beauty in the night sky. But beneath that tranquil mask lies a hellish landscape, a world of unimaginable heat and pressure. It's a reminder that appearances can be profoundly deceiving, and that even the slightest deviation in a planetary story can lead to a radically different ending. Venus is a paradox. It is named after the Roman goddess of love and beauty, and in many ways, it is a stunning object to behold from afar. It is almost the same size as Earth, its diameter just a few hundred kilometers smaller. For a long time, scientists speculated that beneath its cloudy shroud lay a world of lush jungles, steaming swamps, or perhaps even vast oceans. But the reality revealed by robotic probes in the latter half of the 20th century was far more grim. The atmosphere of Venus is its most defining and most devastating feature. It is a runaway greenhouse, a thick, poisonous blend of carbon dioxide with clouds of sulfuric acid. This atmospheric blanket is so dense that it traps the sun's heat, raising the surface temperature to an average of around 870 degrees Fahrenheit. 465 degrees Celsius, hot enough to melt lead and vaporize almost any water that might have once existed. The pressure on the surface of Venus is equally unforgiving. The sheer weight of the atmosphere is over 90 times greater than Earth's equivalent to the pressure you would experience about a kilometer deep in our oceans. Landing on Venus is not a gentle touchdown. It's a descent into a crushing superheated abyss. The longest a lander from Earth has ever survived on the surface was only a little over 2 hours. The probes that did manage to land sent back haunting, desolate images of a rocky orange-hued landscape under a sky of crushing murky yellow. The sun, if you could even see it, would appear as a diffused, hazy point of light, its energy transformed into an inescapable furnace. This runaway greenhouse effect is a powerful scientific concept and a cautionary tale. It is the process by which a planet's atmosphere traps heat and continues to warm itself in a self-reinforcing cycle. On Earth, our atmosphere has some greenhouse gases like carbon dioxide and water vapor, which are essential for keeping our planet warm enough for life. But on Venus, a slight difference in its early history, perhaps being just a little too close to the sun, led to a catastrophic feedback loop. As the planet warmed, any water vapor in its early atmosphere would have evaporated, and since water vapor is a powerful greenhouse gas, this would have trapped even more heat, leading to more evaporation. Eventually, the water was completely boiled away, and carbon dioxide spewed from a billion years of volcanic activity took its place, cementing the planet's fate as a scorching, inhospitable oven. One of the most bizarre and intriguing facts about Venus is its slow retrograde rotation. While every other major planet in our solar system rotates in the same direction that it orbits, the Sun, Venus spins backward. Its day is incredibly long-lasting, about 243 Earth days, even longer than its 225-day year. To stand on the surface of Venus would be to experience a truly strange day-night cycle, with the sun rising in the west and setting in the east. The reasons for this backward rotation are still a matter of scientific debate. The leading theory is that a colossal impact with a large celestial body early in the solar system's history knocked the planet over, causing it to spin in the opposite direction. It's a compelling thought, a single ancient collision shaping the very rhythm of an entire world. Beneath the dense clouds, the surface of Venus is dominated by volcanic features. Scientists believe that Venus underwent a period of massive planet-wide volcanism around 300 to 500 million years ago, which resurfaced the entire world. There are no tectonic plates on Venus in the same way there are on Earth. Instead, the surface seems to have been completely remade in one or more global events. It's a violent, cataclysmic history, and it has created a landscape of vast plains, immense shield volcanoes, and what are known as pancake domes, strange flat-topped volcanic features that are unique to this planet. These pancake domes are thought to be formed by incredibly thick, viscous lava. The planet is also home to what are known as coronae, large circular or oval-shaped features that are believed to be formed by plumes of hot-rising magma from deep within the planet's mantle. These coronae are like quiet bruises on the planet's skin, evidence of the immense geological forces at work beneath the surface. It is a world of quiet, simmering internal violence with the potential for eruption and change just below the surface. This raises an interesting philosophical question. Without the constant slow-moving dance of tectonic plates, like on Earth, does a planet experience change in massive, sudden, and violent bursts? The truth is, we don't really know for sure if Venus is still geologically active today, but the evidence of a tumultuous past is etched everywhere on its surface. Despite the crushing pressure and searing heat, the planet's upper atmosphere, around 50 to 65 kilometers above the surface, is surprisingly Earth-like. Temperatures and pressures in this region are comparable to Earth's, and scientists have speculated that this zone could potentially be a target for future exploration, perhaps even for floating airships or habitats. It is a thin, habitable layer in an otherwise deadly world, a sliver of hope in a sea of despair. This brings us back to a profound and lesser-known scientific fact. Some scientists have even theorized about the possibility of microbial life existing in these atmospheric clouds floating in a temperate zone above the hellish landscape. It's a long shot, but the presence of unknown chemical signatures in the atmosphere has fueled this quiet speculation. Could life, against all odds, have found a way to survive and thrive in this most unlikely of places? It's a question that whispers in the dark, a tiny, almost imperceptible hope. Venus, with its scorching surface and thick acid-filled clouds, is a world that feels strangely alive and yet utterly alien. It is a cautionary tale written in the cosmic dust, a powerful reminder of how delicate the balance of a planet's climate can be. It is a silent mirror to Earth, showing us a potential and frightening future. As we leave this beautiful and terrifying world behind its hazy veil, slowly fading in our view, we carry with us a deeper appreciation for the unique and fragile conditions that allow our own planet to thrive. We are a family of planets, and while we share a common parent in the sun, our individual stories are as different as night and day. And now, we turn our attention to our own home, our blue jewel in the cosmic dark. We leave the haunting veiled world of Venus and begin our slow, familiar drift toward the next planet. A sense of homecoming. A quiet sigh of relief begins to settle over our journey. As the distance closes, a vibrant marble of blue and white, streaked with swirls of cloud and flecked with the warm browns and greens of land, comes into view. This is our home. This is Earth. It is a place of profound uniqueness, a world that seems almost custom-made for life, a delicate cosmic jewel in the endless dark. But what makes it so special? So fundamentally different from its scorched and lifeless neighbors? The answer is not one single thing, but an intricate, fragile, and beautiful dance of conditions. A perfect cosmic alignment that has allowed something as improbable as us to exist. At the very heart of this delicate balance is a silent, unseen hero, our planet's magnetic field. Deep within our core, a swirling molten ocean of iron and nickel creates a powerful magnetic field that envelops our planet like an invisible force field. This field, born of a process called the geodynamo, extends far into space, deflecting the vast majority of the sun's harmful solar wind. Without this shield, the solar wind would have long ago stripped away our atmosphere, leaving us a barren, lifeless rock like Mars. This magnetic field is a constant quiet protector, and the aurora we see at the poles are simply the visible remnants of its unceasing struggle with the sun's powerful breath. It's a reminder that even in the quietest moments, our planet is engaged in a cosmic battle for survival. But a magnetic field is not enough. We also have a perfectly tailored atmosphere, a thin precious blanket of nitrogen and oxygen that not only provides the air we breathe, but also acts as a second line of defense against harmful radiation from space. This atmosphere is a complex dynamic system, a dance of gases that traps just enough heat to keep our planet from freezing solid, but not so much that it boils away our oceans like on Venus. This delicate balance, this perfect Goldilocks zone, is a rare and precious thing in the cosmos. It's not too hot, not too cold. It's just right. The atmosphere is a kind of gentle filter, allowing the visible light we need for life to flourish while absorbing the dangerous high-energy radiation that would be lethal to us. It's an atmospheric tapestry woven from the very history of our world, and a testament to the slow, patient work of both geology and biology. Speaking of geology, one of the most fundamental and unique aspects of Earth is the existence of plate tectonics. The Earth's crust is not a single solid shell, but a mosaic of massive interlocking plates that are constantly slowly grinding against, colliding with, and pulling apart from one another. This geological ballet, moving at the speed of fingernail growth, is the engine of our world. It recycles our crust, creates mountains, carves out ocean basins, and is responsible for the gentle shifting of continents. This process is crucial for life. It helps to regulate our planet's temperature by releasing carbon dioxide from volcanoes and sequestering it in rocks, preventing a runaway greenhouse effect. This constant recycling of the Earth's crust is what makes our planet a living, breathing entity, a world of constant renewal and change. A beautiful and lesser-known fact about Earth's history is the concept of a snowball Earth. Around 700 million years ago, geological evidence suggests that the entire planet was almost completely covered in ice from the poles to the equator. This was a world of profound and terrible stillness, a frozen marble in the blackness of space. Yet life found a way to survive. The buildup of carbon dioxide from volcanoes, which could not be absorbed by the frozen oceans and land, eventually created a super greenhouse effect that melted the ice and kick-started a new era of biological diversity. This slow, patient thawing was a geological reset, a quiet prelude to the explosion of complex life that followed. It's a powerful story of planetary resilience and a reminder that our world has endured far more extreme climate shifts than anything we can imagine. The presence of liquid water is perhaps the most obvious and critical factor. Our oceans, which cover over 70% of the Earth's surface, are the cradle of all life. They are a massive thermal reservoir, helping to regulate global temperatures and transport heat around the globe. Water, with its unique properties, such as expanding when it freezes and being an incredible solvent, is the perfect medium for life. The great global ocean currents are like the planet's circulatory system, carrying warmth and nutrients from one corner of the world to the other. They are a constant, gentle force, shaping climates and ecosystems in their quiet, unseen journey. The intricate dance between the Earth and its moon is another key part of this story. Remember how we talked about the lonely moon's promise? Our moon, a disproportionately large companion for our planet, is not just a silent watcher. Its gravitational pull is what creates the tides, the gentle ebb and flow of our oceans. These tides may have played a crucial role in the very origin of life, with the rhythmic washing of nutrients onto shorelines and the creation of unique intertidal ecosystems. The moon also acts as a gravitational stabilizer, keeping Earth's axial tilt, the angle of our rotation, stable. Without the moon's influence, our planet's tilt would wobble dramatically, leading to wild and unpredictable climate changes that would likely make complex life impossible. Our moon is not just a silent companion. It is a vital partner in the cosmic dance of life. This raises an interesting question. What is the true origin of life? We have a rough idea of the chemical conditions of early Earth, a primordial soup of organic molecules and energy sources, like lightning and volcanic vents. But the jump from non-living chemicals to to the very first self-replicating molecule, to that first spark of biological existence, remains one of the greatest unsolved mysteries in science. We have theories, but the truth is, we don't really know for sure how it happened. It is a profound and humbling thought that the very essence of our being, the thing that separates us from the rocks in the oceans, is a process we have yet to fully understand. As we gently drift watching our homeworld spin slowly beneath us, we see a fragile and beautiful masterpiece of cosmic engineering. Every condition, every detail from the molten core to the distant moon, seems to have been meticulously arranged for the sole purpose of creating a place where life could thrive. It is a place of profound beauty, a place of quiet violence, a place of constant renewal, and a place of deep unsolved mysteries. We are not just on a planet. We are a part of a living system, an intricate and beautiful whole. And now, as we turn our gaze from our own home, we will look to its silent, faithful companion, the moon. Having paid our respects to the beautiful fragility of our own planet, we now turn our silent gaze to a familiar face, a constant companion in our night sky. We are drifting away from Earth, but only slightly our journey, taking us to the silent cratered world that has watched over us for billions of years. This is our moon, a world without atmosphere, without water on its surface, and without the tumultuous geological activity that defines our home. It is a place of profound stillness, a lonely traveler in the cosmic dark, but its story is intrinsically tied to our own. Without the moon, the story of life on Earth would be a very different one indeed. The most popular scientific theory for the moon's origin is called the giant impact hypothesis. This theory posits that billions of years ago, when the Earth was still a young molten world, a planet-sized body roughly the size of Mars and named Theia collided with it. This was not a gentle meeting, but a catastrophic planet-shattering event. The immense energy of the collision vaporized much of the impactor and a portion of the Earth's mantle, sending a cloud of superheated debris into orbit around our young planet. Over time, this ring of debris coalesced, a slow, patient gathering of shattered rock and dust, forming the moon we know today. This violent birth explains why the moon is made of material similar to Earth's crust and mantle, but lacks the large iron core that would have sunk into the Earth after the impact. It's a beautiful, violent origin story, a reminder that even our most serene celestial neighbor was born from chaos. Looking at the moon's face, we can read its ancient history like a book. The countless craters are not random scars. They are a chronicle of the early solar system, a record of the cosmic bombardment that both Earth and the moon endured. Because the moon has no atmosphere or geological activity, these impact craters have been preserved for billions of years, a silent gallery of a bygone era. The two main types of terrain on the moon are the bright, rugged highlands and the darker, smoother plains called Maria Latin for seas. These Maria are not bodies of water, but vast plains of solidified basaltic lava that flowed into the great basins created by the most massive impacts. It's a surface where silence is the only sound, a place where time seems to have stood still, preserving a memory of the universe's chaotic youth. The moon's relationship with Earth is a powerful and intimate one. As we talked about before, the moon's gravity creates the tides in our oceans, a constant, rhythmic pull on our planet. But the moon's influence extends beyond that. It is slowly, imperceptibly pushing our planet away. Each year, the moon drifts about 3.8 centimeters farther from Earth. This phenomenon is a consequence of the gravitational interaction between the moon and Earth's tidal bulges. As the Earth rotates, it drags the tidal bulges slightly ahead of the moon, and the gravity of these bulges pulls on the moon, giving it a tiny boost that pushes it into a slightly higher orbit. This gradual retreat is a humbling fact. Our closest companion is slowly, quietly leaving us. It is a slow-motion farewell, a reminder of the universe's profound and patient movements. A truly mind-bending and lesser-known fact about the moon is the twin paradox in a cosmic context. The famous thought experiment suggests that a person traveling at near the speed of light would age more slowly than their twin on Earth. While the moon is moving far too slowly for this effect to be noticeable, the concept of gravitational time dilation, a key component of Einstein's theory of relativity, is in play. Time actually moves slightly faster on the moon's surface than it does on Earth's, because the moon is in a weaker gravitational field. The difference is minuscule, a matter of mere microseconds over a lifetime, but it is a real effect. It means that an astronaut living on the moon would in fact age ever so slightly faster than someone living on Earth. It's a beautiful and bizarre example of how the fabric of space and time is not uniform, but is warped and stretched by the presence of mass. The moon is also a world of extremes. Because it has no atmosphere, its surface is exposed to the full force of the sun's radiation. During the long lunar day, temperatures can soar to 250 degrees Fahrenheit, 120 degrees Celsius, while during the equally long lunar night, they can plunge to a frigid minus 250 degrees Fahrenheit, minus 150 degrees Celsius. This is not a world of gentle warmth or cool breezes, but a place of searing heat and bitter cold. Yet just like Mercury, scientists have found evidence of water ice in the permanently shadowed craters at the lunar poles. This discovery, made by a NASA probe that intentionally crashed into a polar crater, suggests that even in this seemingly dead world, there might be resources that could support future human exploration. It is a testament to the hidden resilience of water and the surprising secrets that can be locked away in eternal shadow. The moon has no intrinsic magnetic field, but it does have localized magnetic fields in certain areas, known as magnetic anomalies. These areas are thought to be remnants of a time when the moon did have a magnetic field, possibly generated by a small churning liquid core. This field would have died out as the moon's core cooled, but the remnants of its power remain frozen into the lunar rocks. It is a ghostly echo of a bygone era, a quiet whisper of a more geologically active past. This raises a philosophical question. Can a world truly ever die in the cosmic sense? Or do its echoes and memories persist, forever waiting for us to discover them? The truth is, we don't really know for sure, but the moon's surface is full of these quiet, unanswered questions. The moon's gravity is also responsible for stabilizing Earth's axial tilt, as we talked about earlier. Without its stabilizing influence, Earth's tilt would wobble far more dramatically over time, leading to extreme and unpredictable climate changes that would make it very difficult for complex life to thrive. The moon is not just a silent watcher. It is a vital partner in the cosmic dance, an invisible hand that keeps our planet on an even keel. It is the steady anchor in our quiet corner of the universe. As we drift away from this beautiful silent sphere, we are left with a sense of its profound and lonely dignity. It is a world of quiet contradictions, born from immense violence, yet a symbol of serenity. A dead world, yet a partner in the story of life. The moon is more than just a satellite. It is a witness to our history, a keeper of our secrets, and a reminder of the patient, powerful forces that shape our universe. And with our quiet companion now fading behind us, we turn our attention to the next member of the solar family, the rusty red planet that has long captured our imagination. Mars, leaving our quiet moon behind. Our journey now takes us to a world that has long captured the human imagination. As we drift further from the familiar blue and white of our home, a new color dominates the view, a deep, rusty red. This is Mars, the red planet, a world of silent canyons, immense volcanoes, and a haunting, desolate beauty. It is a planet of profound nostalgia, a world that seems to be in a state of suspended animation, holding within its dusty plains the echoes of a lost past. We feel a strange sense of kinship with this place, for it is perhaps the most Earth-like of our neighbors, a world that once had liquid water, and a world where we may one day send our own kind. The defining characteristic of Mars is its rusty hue, a color that gives it its ancient nickname. This red is not a feature of its core or mantle, but of its surface, which is covered in vast amounts of iron oxide or rust. This fine dusty soil called regolith is a constant presence on the planet, kicked up into the thin atmosphere by global dust storms that can shroud the entire world for months at a time. The red dust of Mars is a silent reminder of a long, slow process of decay, a world where the very rocks have been oxidized over billions of years, a planet turning to rust in the quiet cold of space. It's a powerful metaphor for a world that seems to have lived its most vibrant life long ago. But Mars was not always a rusty desert. A wealth of evidence gathered by rovers and orbiting probes suggests that billions of years ago, Mars was a much warmer, wetter world. Ancient riverbeds, dried-up lake beds, and mineral formations that only form in the presence of water are etched into the Martian surface. It's a powerful and haunting story written in the geology of the planet. Scientists believe that early Mars had a thicker atmosphere and a magnetic field, both of which protected the planet and allowed liquid water to flow freely. Vast oceans and rivers may have covered large parts of the northern hemisphere. The presence of these ancient geological features raises the most profound question about this world. If there was liquid water, could there have been life? The search for evidence of ancient microbial life on Mars is one of the primary drivers of our robotic explorations, a quiet, patient quest to understand if we are truly alone in the universe. The mystery of what happened to this once hospitable world is a key part of the Martian story. Scientists believe that as the planet's small core cooled and solidified, its protective magnetic field faded away. Without that shield, the sun's powerful solar wind began to strip away the Martian atmosphere particle by particle over millions of years. As the atmosphere thinned, the pressure on the surface dropped and liquid water could no longer exist. The planet's oceans and rivers either evaporated into space or froze into the permafrost beneath the surface, leaving behind a cold, dry, and desolate world. This slow, gradual transformation is a stark reminder of the fragile balance of planetary existence and a cautionary tale about the consequences of losing a protective magnetic field. One of the most impressive features of Mars is its immense geography. The planet is home to the largest volcano in the solar system, Olympus Mons, a shield volcano so vast that it would cover the state of Arizona. It stands over 25 kilometers high, nearly 3 times the height of Mount Everest. Next to it is the equally impressive Valle Marineris, a colossal canyon system that is over 4,000 kilometers long enough to stretch across the continental United States. These features are a testament to the planet's past geological power, a time when immense volcanic forces were at work. The sheer scale of these features is mind-bending, and they speak to a world that once had the energy and the geological processes to create wonders that dwarf anything on Earth. Mars also has a pair of small, irregularly shaped moons, Phobos and Deimos. They are not spherical like our moon, and their heavily cratered surfaces suggest they are likely captured asteroids pulled into orbit by Mars's gravity billions of years ago. Phobos, the closer of the two, orbits so fast that it rises in the west and sets in the east, a bizarre and beautiful orbital ballet. It is also slowly spiraling inward, and in about 50 million years, it will likely be torn apart by Mars's gravity, creating a temporary ring system around the planet before its fragments crash to the surface. It is a slow cosmic tragedy in the making, a quiet reminder that nothing in the universe is permanent. A lesser-known fact about Mars is that it has seasons much like Earth, due to its axial tilt being very similar to our own. But because Mars's orbit is more elliptical, its seasons are more extreme in the southern hemisphere, where the planet is closer to the sun during the summer. This causes the massive ice caps at both poles, made of a mix of water ice and frozen carbon dioxide, to grow and shrink with the seasons. The seasonal cycle of the polar caps, a beautiful and slow rhythm of freezing and sublimation, is one of the most dynamic processes on the Martian surface. It is a quiet echo of a more vibrant Earth-like past, a memory of a time when the planet had a global water cycle. This raises a fascinating and poignant question. Is there any life on Mars today? While the conditions are harsh and the surface is inhospitable, scientists have found evidence of liquid water flowing on the planet's surface in the form of briny streaks on crater walls, and there is a massive amount of water ice beneath the surface. The search is on for life in these subterranean oases. Could there be microbial life clinging to existence deep within the Martian soil, protected from the radiation and cold? The truth is, we don't really know for sure, but the possibility remains a quiet hope that guides our rovers and fuels our dreams of a future on the red planet. As we drift away from this beautiful rusty world, we are left with a feeling of both wonder and sorrow. Mars is a world of immense power and quiet tragedy, a cosmic history book waiting to be fully read. It is a testament to the fact that even a planet can lose its way, can lose the conditions that make life possible. But it is also a world of enduring hope, a place where the search for life continues, a silent frontier that beckons us to look to the stars and ask what might have been. And with Mars now fading in our view, we prepare to venture further out into the vast, cold emptiness between the inner and outer solar system. We have crossed the vast, empty chasm between the inner planets, those small rocky worlds forged in fire, and now we arrive in a new and different realm of our solar system. The air of solitude that defined the inner worlds gives way to a sense of immense scale and quiet, colossal power. A new presence dominates the view, a magnificent swirling marble of cream orange and brown, a world so large it makes all the others seem like mere pebbles. This is Jupiter, the king of the planets, a gas giant of unimaginable proportions. It is a world without a solid surface, a silent monarch that has held court over our solar system for billions of years, a massive ancient anchor in the cosmic sea. Jupiter is a world of superlatives. Its mass is more than 2.5 times that of all the other planets in our solar system combined. If you were to hollow it out, you could fit over 500 Earths inside. But its most defining characteristic is its composition. It is not a rocky world like our own, but a massive ball of gas and liquid, primarily hydrogen and helium. As you descend into Jupiter's atmosphere, the gas becomes denser and denser until the pressure is so immense that the hydrogen gas is compressed into a liquid state. Deeper still, the pressure becomes so great that the hydrogen takes on the properties of a metal, creating a swirling ocean of liquid metallic hydrogen. This incredible substance is believed to be the source of Jupiter's powerful magnetic field, a field so strong that it is over 20,000 times more powerful than Earth's. It is a world where the very elements behave in ways we can barely comprehend, a place where physics itself seems to bend to the will of immense pressure and gravity. The most famous feature of Jupiter is its Great Red Spot, a colossal anticyclonic storm that has been raging for at least 150 years and perhaps for much longer. It is a storm so vast that it is wider than Earth, a powerful swirling vortex of clouds and gases that is a testament to the sheer raw power of the planet's atmosphere. This storm is a dynamic and ever-changing entity, its color and size fluctuating over time, a beautiful and terrifying example of atmospheric violence on a cosmic scale. But the red spot is not the only storm. Jupiter's atmosphere is a constant chaotic ballet of powerful storms, jet streams, and banded cloud patterns, each one a testament to the incredible forces at work within the planet. The lighter bands are called zones, and the darker ones are belts, and the interplay between them creates a beautiful hypnotic tapestry of light and shadow, a quiet, mesmerizing show of planetary weather. One of the most fascinating and bizarre facts about Jupiter is its influence on the rest of the solar system. Its immense gravitational pull has shaped the orbits of countless comets and asteroids, often flinging them out into the deep cosmos or capturing them into its own orbit. Jupiter is often called the cosmic vacuum cleaner a silent protector of the inner solar system, deflecting a great deal of the cosmic debris that might have otherwise impacted Earth. In 1994, we saw a powerful example of this when the comet Shoemaker-Levy 9, which had been captured by Jupiter's gravity, was torn apart and its fragments crashed into the gas giant, creating immense Earth-sized scars in its atmosphere. It was a spectacular and sobering display of Jupiter's power, a reminder that we owe a great deal of our own peaceful existence to this massive silent guardian. Jupiter is also a world of moons, a miniature solar system in its own right. It has over 90 confirmed moons, but the 4 largest and most famous are the Galilean moons named after their discoverer, Galileo Galilei. These 4 worlds, Io, Europa, Ganymede, and Callisto, are each a fascinating story unto themselves. Io is the most volcanically active body in the solar system, a world constantly reshaped by the immense tidal forces exerted by Jupiter's gravity. Europa is a mysterious ice-covered world with strong evidence suggesting a vast subsurface ocean of liquid water, a tantalizing prospect in the search for extraterrestrial life. Ganymede is the largest moon in the solar system, bigger than the planet Mercury, and it even has its own magnetic field. And Callisto is a heavily cratered ancient world, a silent, lonely witness to the solar system's history. These 4 worlds are a testament to the diversity of planetary bodies even within a single system. A lesser-known fact about Jupiter is its faint and mysterious ring system. While not as magnificent as Saturn's, Jupiter's rings are a beautiful and delicate feature made of tiny particles of dust from its inner moons. They are believed to be formed from the constant bombardment of these moons by micrometeorites, with the dust being captured by Jupiter's powerful gravity. It's a ghostly, almost invisible feature, a quiet whisper of a ring system, a testament to the constant subtle erosion and creation that is happening all around us in the cosmos. This raises an interesting question. Is there a core to Jupiter, a solid rocky center to this gas giant? The truth is, we don't really know for sure. The pressure and temperature at the center of the planet are so extreme that it's impossible for us to know what's there with certainty. It is believed that there may be a solid rocky core, but it could also be a kind of supercompressed, ultra-dense form of matter that defies our current understanding. The very heart of Jupiter remains a profound mystery, a final unyielding secret at the center of our solar system's king. As we drift away from this beautiful and terrifying world, we are left with a feeling of deep humility. Jupiter is a world of immense quiet power, a place where the forces of nature are at their most extreme. It is a silent protector, a cosmic anchor, a world of beautiful violent storms and mysterious hidden oceans. It is a world that commands our respect and deepens our sense of wonder. And with the king of our solar system now fading behind us, we prepare to visit its most elegant and famous neighbor, the ringed jewel of the cosmos, Saturn. Leaving the silent, colossal power of Jupiter behind, our journey now brings us to the most elegant and instantly recognizable world in our solar system. As we approach, a new sight fills our view. A serene, yellowish-brown sphere adorned with a breathtaking, majestic halo of light. This is Saturn, a gas giant of immense scale, but one whose defining feature is not its size alone, but the intricate and beautiful symphony of its rings. It is a world that feels more like a work of art than a planet, a quiet, mesmerizing jewel that commands our attention and deepens our sense of wonder. Saturn, much like Jupiter, is a gas giant, a massive sphere composed almost entirely of hydrogen and helium. Its size is immense. It is the second largest planet in our solar system, with a diameter about 9 times that of Earth. But its density is remarkably low. If you could find a bathtub large enough, Saturn would float in water. This is a powerful, almost whimsical image, and it speaks to the fact that this is a planet of incredible lightness, a world of immense size, and surprisingly little substance. Its atmosphere, much like Jupiter's, is a constant ballet of storms and swirling clouds, though they are not as distinctly banded. The planet's winds are some of the fastest in the solar system, with speeds reaching over 1,800 kilometers per hour. This immense atmospheric energy is a testament to the powerful unseen forces at work within the planet's interior. But the true star of Saturn's story is its spectacular ring system. These rings are not solid, but are a breathtaking collection of countless billions of ice particles, dust and rock ranging in size from tiny grains to giant boulders. They orbit the planet in a vast, thin disk, a celestial ribbon of frozen wonders. The rings are so thin, in fact, that if you could scale them down to the size of a football field, they would be no thicker than a single sheet of paper. The sheer scale and beauty of the rings are difficult to comprehend, a testament to the patient, quiet work of cosmic forces. It's like a great shattered chandelier of ice, a silent, beautiful ruin from the dawn of our solar system. The origins of Saturn's rings are still a matter of scientific debate and a profound mystery. The most widely accepted theory is that the rings are the remnants of a shattered moon, or perhaps a comet or asteroid that ventured too close to Saturn and was torn apart by the planet's immense tidal forces, a process known as the Roche limit. The fragments of the moon or comet would have been spread out into a disk around the planet, and over billions of years, collisions and gravitational interactions would have sculpted them into the intricate and beautiful system we see today. Another theory suggests that the rings are as old as the planet itself, a remnant of the primordial material that formed Saturn. But that idea is challenged by the rings' relatively pristine appearance. The truth is, we don't really know for sure how they were formed, and their origin remains one of the solar system's most compelling unsolved mysteries. Saturn is also a world of moons, a staggering collection of over 145 known satellites, more than any other planet. This is a miniature solar system in its own right, a testament to the immense gravitational influence of the planet. Each moon is a unique world with its own story. There is Titan, the second largest moon in the solar system, a world with a dense, nitrogen-rich atmosphere and liquid methane lakes on its surface, a place that feels like a quiet, chilly version of early Earth. There is Enceladus, a small icy moon that is actively spewing plumes of water vapor and ice from its south pole, a clear indication of a vast subsurface ocean of liquid water, a tantalizing prospect for the search for life. The tiny moon Pan, a shepherd moon that orbits within the rings, looks like a cosmic ravioli, its unique shape sculpted by the gravitational forces of the ring particles. These moons are a constant source of wonder, each one a different window into the incredible diversity of our solar system. A lesser-known fact about Saturn is the bizarre hexagonal storm at its north pole. This is a massive, persistent cloud pattern, a six-sided vortex of immense proportions. The hexagon is over 30,000 kilometers across, and the winds within it are incredibly fast. The reason for its precise geometric shape is still a complete mystery. It is believed to be a kind of standing wave in the planet's atmosphere, but the exact mechanism that creates and maintains such a perfect shape is not understood. It is a stunning example of the complex and beautiful patterns that can emerge from the chaotic forces of a planetary atmosphere. The Cassini division. The largest gap in Saturn's rings is another beautiful example of a cosmic phenomenon. It is a wide gap of darkness that separates the A and B rings. This gap is not empty, but is a region with far fewer particles, and it is believed to be caused by the gravitational influence of a single moon, Mimas, which orbits Saturn farther out. Mimas's gravity creates a resonance with the ring particles, pulling them away from this region and clearing a path like a shepherd herding a flock of sheep. It's a powerful and poetic example of the invisible yet constant influence of gravity, a silent sculptor of the solar system's most beautiful feature. As we drift away from this beautiful and mesmerizing world, we are left with a feeling of deep serenity. Saturn is a planet of quiet elegance, a world that seems to be in a constant state of patient, rhythmic beauty. Its rings are a powerful reminder of the delicate and chaotic forces that shape our universe, and its moons are a testament to the incredible diversity of worlds that can exist in even a single corner of the cosmos. It is a world of unresolved questions and quiet, stunning beauty. And with the ringed jewel of our solar system now fading behind us, we prepare to venture even further out into the cold, distant realm of the ice giants. We leave the beautiful, majestic realm of Saturn, its rings slowly diminishing into a single distant line of light. Our journey now takes us to a darker, colder corner of the solar system, a place where sunlight is a pale, ghostly whisper. As we approach a new world, reveals itself a featureless pale blue sphere, almost entirely devoid of the vibrant colors that have characterized our journey so far. This is Uranus, an ice giant of profound mystery, a world that seems to be in a state of perpetual tilted slumber. It is a world of quiet contradictions, a planet that spins on its side, a strange, silent figure dancing its own peculiar ballet around the sun. Uranus is a giant world, the third largest planet in our solar system, with a diameter about 4 times that of Earth. But unlike the gas giants, Jupiter and Saturn-Uranus is an ice giant. This is not to say that it has a solid surface of ice. Rather, it means that its composition is different, consisting of a dense hot fluid of icy materials, water, methane, and ammonia surrounding a small rocky core. The immense pressure within the planet keeps these substances in a supercompressed liquid state, a kind of planetary ocean that is both incredibly hot and incredibly dense. The pale blue color of the planet comes from the methane gas in its upper atmosphere, which absorbs the red light from the sun and reflects the blue. It's a beautiful soft color, a quiet mask for a world of immense internal pressure and heat. The most bizarre and defining characteristic of Uranus is its extreme axial tilt. While all the other planets in our solar system spin on their axis in a relatively upright position, Uranus is tilted on its side, rotating almost perfectly horizontally. Its axis is tilted at an angle of 97.77 degrees. This means that for a portion of its 84-year orbit, one pole is pointed directly at the sun, while the other is plunged into 42 years of continuous darkness. Then, as the planet continues its slow journey, the equator faces the sun, and the 2 poles get their turn in the day-night cycle. The seasons on Uranus are therefore incredibly extreme and long. This bizarre tilt is a profound mystery, and the leading theory is that a colossal planet-sized object collided with it billions of years ago, knocking it over and forever changing its quiet rhythmic ballet. It's a beautiful and violent origin story, a testament to the chaotic forces that shaped the early solar system. A fascinating and lesser-known fact about Uranus is its incredibly cold atmosphere. It has the coldest planetary atmosphere in our solar system, with temperatures dropping as low as -371 degrees Fahrenheit, -224 degrees Celsius in its cloud tops. This is a perplexing fact, as Uranus is farther from the sun than Neptune, which is warmer. Scientists believe that Uranus's extreme tilt might be the reason for this coldness. The impact that knocked it over may have also released much of its internal heat, leaving it with a relatively cool interior compared to the other giant planets. This lack of internal heat means less atmospheric convection and less dynamic weather, which is why Uranus appears so featureless from our vantage point. It is a world of silent, deep-seated cold, a planet that seems to be in a state of suspended geological animation. Uranus also has a faint ring system, a beautiful and delicate feature that was only discovered in 1977. These rings are not as spectacular as Saturn's, but they are unique in their own right. They are dark and narrow, composed of tiny dust particles and rocks, and they are believed to be relatively young. The reason for their darkness is still a mystery, but it is thought to be a result of the constant bombardment of radiation from the sun, which has burned the surface of the particles. The rings are also shepherded by a system of small inner moons, which keep them from dissipating, a testament to the subtle but constant influence of gravity. The planet is also a world of moons, a collection of 27 known satellites, each named after characters from the works of Shakespeare and Alexander Pope. These moons are small and dark, and many of them are believed to be captured asteroids. They are a collection of quiet, lonely worlds, each with its own story. There is Miranda, a bizarre-looking moon, with a patchwork surface of canyons, grooves and cliffs, a testament to a chaotic and violent geological past. There is Ariel, a moon that shows signs of cryovolcanism, a kind of icy volcanism, where geysers of liquid ammonia and water erupt from the surface. These are worlds that are not entirely dead, but are engaged in a slow, patient process of change, a quiet, icy life of their own. This raises an interesting question. Does Uranus have a magnetic field? It does, and it is a truly bizarre one. Unlike Earth and the other giant planets, where the magnetic field is aligned with the rotational axis and centered on the planet's core, Uranus's magnetic field is both tilted and off-center. It is tilted by a staggering 59 degrees from its rotational axis, and it is offset from the planet's physical center. This lopsided and bizarre field is a profound mystery, and it suggests that the magnetic field is not generated in the core, but in a shallower layer, perhaps in the vast ocean of super-compressed water and ammonia that surrounds the core. The truth is, we don't really know for sure, and this lopsided field is one of the most compelling unsolved puzzles in planetary science. As we drift away from this quiet, sleepy giant, we are left with a feeling of deep humility and wonder. Uranus is a world that seems to defy our expectations, a planet that has been shaped by a cataclysmic past and now exists in a state of quiet, serene difference. Its bizarre tilt, its cold, featureless atmosphere, and its lopsided magnetic field all speak to a story that is profoundly unique and deeply mysterious. It is a quiet world, a silent, sleepy giant on the edge of our solar system. And with the ice giant now fading behind us, we prepare to visit the final stop on our planetary tour, the most distant and mysterious of all, Neptune. The quiet, tilted beauty of Uranus now fades into the immense blackness behind us. Our journey has brought us to the final planetary outpost, the last of the great worlds in our cosmic family. Here, in the deepest, coldest reaches of our solar system, a world of profound mystery and ethereal beauty awaits. We are now approaching Neptune, a magnificent, deep blue sphere, a world of powerful winds and dark, swirling storms. It is a world that was discovered not by sight, but by mathematics, a silent, unseen presence whose gravitational pull whispered a secret to humanity before a single telescope could confirm its existence. Neptune is another ice giant, a twin in size and composition to Uranus. Its striking deep blue color is a product of the higher concentration of methane in its upper atmosphere compared to Uranus. This methane absorbs red light and reflects blue, creating a vibrant, beautiful hue that makes it stand out even from this incredible distance. But beneath this tranquil exterior lies a world of unimaginable atmospheric violence. Neptune is the windiest planet in our solar system, with winds that can reach speeds of over 2,000 kilometers per hour, a constant chaotic gale that dwarfs any storm we have ever experienced on Earth. It is a world of extreme restless energy, a planet in a perpetual state of furious motion. The most famous storm on Neptune, observed by the Voyager 2 probe, was a colossal storm called the Great Dark Spot. It was a massive Earth-sized vortex in the planet's southern hemisphere, a silent, menacing eye of a storm that was a testament to the planet's internal power. Unlike Jupiter's Great Red Spot, the Great Dark Spot was an ephemeral feature disappearing just a few years after its discovery. But other smaller dark spots have been observed, a reminder that the planet's atmosphere is in a constant state of flux, a chaotic and powerful symphony of change. This constant, relentless motion is a profound mystery. Given its incredible distance from the Sun, Neptune receives far less energy to power its storms than any other planet. The source of this internal energy, this quiet violence, is still not fully understood. A lesser-known fact about Neptune is its unique moon Triton. It is the largest of Neptune's 14 known moons, and it is a world of incredible strangeness. Triton is a geological marvel with a surface of frozen nitrogen ice volcanoes that spew plumes of nitrogen gas and dust, and a bizarre retrograde orbit. It is the only large moon in our solar system to orbit its planet in the opposite direction of the planet's rotation. This retrograde orbit suggests that Triton was not formed in place with Neptune, but was captured by the planet's immense gravity long ago. It is believed to have been a Kuiper Belt object, a lonely wanderer in the deep cosmos that was pulled into Neptune's orbit. This capture would have been a violent, chaotic event, and it is believed to have reshaped Triton into the strange active world we see today. The discovery of Neptune is a beautiful story of science and human ingenuity. In the 19th century, astronomers noticed that the orbit of Uranus was not behaving as predicted by Newton's laws of gravity. It was being pulled and tugged by some unseen gravitational force. Two astronomers, Urbain Le Verrier and John Couch Adams, working independently, used mathematics to calculate where this unseen planet must be. Their calculations were so precise that when a telescope was pointed to that exact spot, Neptune was discovered within a single degree of the predicted location. It was a stunning confirmation of the power of mathematical physics and a testament to the fact that we can understand the universe not just by seeing it, but by listening to its subtle gravitational whispers. This raises a philosophical question. Does the universe have a kind of inherent logic, a mathematical grammar that we can learn to read, even for things that we cannot yet see? The truth is, we don't really know for sure, but the discovery of Neptune suggests that the universe holds its secrets in plain sight, if we only know how to look. Neptune also has a faint ring system, a series of 5 main rings, named after the astronomers who made important contributions to its study. These rings are dark and clumpy, composed of microscopic dust and perhaps some larger fragments of rock. They are not continuous, but are a series of distinct arcs, a beautiful and mysterious feature that is still not fully understood. It is believed that the gravitational influence of small moons acting as shepherds may be responsible for the clumping of the ring material into these arcs. The deep blue of Neptune is a quiet mask for a world of immense and powerful forces, a place where a gentle exterior hides a chaotic and violent interior. It is a world that seems to be in a constant state of flux, a powerful distant outpost on the edge of our solar system. The beauty of its color and the violence of its storms make it a world of profound contradictions, a final, mysterious jewel in the cosmic dark. And with Neptune now fading into the distance, we venture beyond the familiar planets into a new and unknown realm of our solar system, a place of frozen wanderers and distant echoes. The final planetary outpost of Neptune now fades into the great cosmic dark, its deep blue a vanishing point on our journey. We are in a new and different territory, now a vast, frigid frontier that begins just beyond Neptune's orbit and stretches out into the abyss. This is the Kuiper Belt, a great donut-shaped ring of icy bodies, a region that is a kind of cosmic deep freeze, a warehouse of the primordial building blocks of our solar system. It is a place of profound stillness and quiet, where 1,000 icy worlds drift in a slow, patient dance around the distant sun. The Kuiper Belt is the home of dwarf planets like Pluto, a world that was once considered a full-fledged planet, but is now understood to be the king of this frosty realm. It is also the home of countless smaller icy bodies, called Kuiper Belt objects, KBOs, which are believed to be the source of many of the short-period comets that occasionally grace our inner solar system. These are not large rocky worlds like the inner planets, but a diverse collection of frozen worlds, some with atmospheres, some with moons, each with its own unique and quiet story. It is a kind of hidden gallery, a collection of forgotten worlds from the dawn of our solar system. The sheer scale of the Kuiper Belt is difficult to comprehend. It is estimated to be over 20 times as wide as the asteroid belt and hundreds of times more massive, but the objects within it are so far apart and so tiny that it is a place of immense emptiness. The sun from this distance is no longer a brilliant life-giving orb, but a distant powerful star, a point of light in the sky that is barely brighter than any other star. The light here is a pale ethereal whisper, and the warmth is non-existent. It is a world of permanent, deep-seated cold, a place where a gentle warmth would be as alien a concept as a fish in the desert. A truly fascinating and lesser-known fact about the Kuiper Belt is the concept of plutonos. These are objects within the Kuiper Belt that are in a special orbital resonance with Neptune. This means that for every 2 orbits of the Sun that a plutono makes, Neptune completes exactly 3. This gravitational synchronization is a powerful and elegant example of the subtle yet powerful influence of gravity. It is a beautiful cosmic ballet, a synchronized dance of immense proportions that has been playing out for billions of years. Pluto itself is the largest of these plutonos, and its orbit is a perfect example of this resonance, a quiet, rhythmic dance that keeps it from ever colliding with its much larger neighbor. The discovery of the Kuiper Belt was a slow and patient process, a testament to the dedication of astronomers. For decades, it was a theoretical concept, a logical extension of our understanding of how the solar system was formed. The first KBO was discovered in 1992, and since then, thousands of others have been found, each one a tiny piece of the puzzle that is our cosmic history. The existence of the Kuiper Belt is a powerful confirmation of our models of solar system formation, which suggest that the outer regions of the protoplanetary disk, where it was too cold for rocky planets to form, would have been a perfect place for icy bodies to coalesce. The Kuiper Belt is a living fossil, a frozen remnant of the material that formed the outer planets, a time capsule from the dawn of our solar system. This raises an interesting question. Is the Kuiper Belt the end of our solar system? The truth is, we don't really know for sure. The outer edge of the Kuiper Belt is not a sharp boundary, but a gradual thinning out of objects. And beyond that, there is a theoretical spherical cloud of icy bodies that is believed to be the true edge of our solar system, a place of even more profound emptiness and cold. But for now, the Kuiper Belt is the end of the familiar, a final outpost before we enter the realm of pure speculation and theory. The dwarf planet Pluto is the most famous resident of the Kuiper Belt, a world that has captured our hearts and our imaginations. It is a small world, but a geologically active one with a heart-shaped glacier of nitrogen ice and a thin atmosphere that freezes and thaws with its long elliptical orbit. It is a world of quiet wonders, a beautiful and surprising place that has defied our expectations. It has a collection of moons, with its largest Charon being so large in comparison that Pluto and Charon are often considered a binary system, 2 worlds locked in a gentle cosmic embrace. As we drift away from this great frozen gallery, we are left with a feeling of profound scale and quiet dignity. The Kuiper Belt is a world of beginnings and endings, a place where the story of our solar system begins to fade, but where the promise of discovery still burns bright. It is a testament to the fact that even in the most distant and empty corners of the cosmos, there is still beauty, still mystery, and still a story to be told. And with the frozen gallery of the Kuiper Belt now fading behind us, we prepare to venture even further out into the truly uncharted territory of our solar system, the theoretical Oort cloud. We have ventured beyond the familiar planets and their rings, beyond even the vast icy gallery of the Kuiper Belt. Now, we are in a place of profound emptiness, a realm of pure theory and cosmic distance, a sphere of icy bodies that is believed to be the true edge of our solar system. We are in the Oort cloud, a place that has never been seen directly, a final fading echo of our home, It is a vast, spherical shell of icy bodies, a cosmic halo that envelops our entire solar system in a gentle cold embrace, a silent, unmoving anchor in the great dark. The Oort cloud is not a belt or a disk like the asteroid belt or the Kuiper belt. It is a massive, spherical cloud of icy bodies, a cosmic bubble that extends from a distance of about 2,000 to 5,000 AU astronomical units from the Sun, to perhaps as far as 50,000 to 100,000 AU a distance that is a quarter to a half of the way to the next star. To put that into perspective, the Sun from this distance would be nothing more than a powerful star, a point of light in the sky that is no brighter than any other star in the galaxy. The light here is a ghost, a memory of warmth from a place that is almost unimaginable in its distance. The existence of the Oort cloud is a hypothesis, a brilliant scientific theory that was first proposed by astronomer Jan Oort in 1950. The theory was a way to explain the origin of long-period comets. Those comets with orbits so vast and so long that they only visit our inner solar system once every thousands or even millions of years. These comets come from every direction in the sky, and their orbits are highly elliptical, a sign that they are not from the same disk-shaped region as the planets and the Kuiper belt. The only way to explain this was to hypothesize the existence of a vast spherical cloud of icy bodies, a kind of cometary reservoir, a silent ancient wellspring from which these cosmic wanderers emerge. The Oort cloud is believed to have been formed billions of years ago in the chaotic early days of our solar system. As the great planets, especially Jupiter and Saturn, were forming, their immense gravitational pull would have flung out countless billions of icy planetesimals, the building blocks of the outer planets, into the deep cosmos. These icy bodies, scattered by the gravitational slingshot of the giant planets, would have formed a great spherical cloud, a halo of cosmic debris that would eventually become the Oort cloud. It's a beautiful poetic idea. The very chaos and violence of the solar system's formation is what created its most serene and distant feature. The bodies within the Oort cloud are incredibly far apart, and the space between them is a vast, unimaginable emptiness. A star passing too close to the solar system, or a distant gravitational tug from the Milky Way's galactic tide, could gently nudge one of these icy bodies out of its quiet slumber. Once nudged, the object would begin a long, slow fall toward the Sun, a journey that could take millions of years before it finally emerges as a long-period comet, a beautiful fiery guest from the deepest, most ancient corner of our solar system. It's a cosmic cycle of immense scale and patience, a beautiful quiet rhythm that has been playing out for billions of years. A fascinating and lesser-known fact about the Oort cloud is the concept of a detached object. These are icy bodies in the outer solar system, like the dwarf planet Sedna, whose orbits are so distant and so highly elliptical that they cannot be explained by the gravitational influence of the known planets alone. This has led some scientists to hypothesize the existence of a massive unseen planet, Planet 9, whose gravitational pull is shaping the orbits of these distant objects. This is a quiet whisper from the deep cosmos, a tantalizing hint of an undiscovered world, a silent, unconfirmed presence that continues to shape the orbits of the most distant members of our solar system family. The truth is, we don't really know for sure if a Planet 9 exists, but the existence of these detached objects is a powerful hint that there are still profound mysteries to be discovered at the edges of our home. The Oort cloud is a place of endings and beginnings. It is the final boundary of our solar system, the place where our Sun's gravitational influence finally begins to lose its grip. But it is also a place of beginnings, the quiet birthplace of the comets that occasionally grace our night skies, the ancient messengers from the dawn of our solar system. It is a place of profound solitude and unimaginable cold, a testament to the fact that even in the most empty and distant corners of the cosmos, there is still beauty, still mystery, and still a story to be told. As we drift our silent vessel, now turning back toward the faint, distant light of the Sun, we are left with a feeling of deep humility and wonder. The Oort cloud is a place of immense scale and quiet patient beauty, a silent, unmoving testament to the long, slow work of cosmic forces. And with the theoretical edge of our solar system now behind us, we prepare to retrace our steps to visit the comets and asteroids that have long been a part of our cosmic story. Having drifted through the vast emptiness of the Oort cloud, and now turning our gaze back toward the sun, we are re-entering a more familiar, though no less mysterious part of our cosmic home. As we journey inward, we are no longer looking at the great quiet planets, but at the smaller, more transient members of the solar system family. We are now in the realm of comets, those beautiful ghostly wanderers that occasionally grace our night skies. They are like cosmic snowballs, ancient messengers from the deep freeze of our solar system, and each one is a time capsule from the very beginning of everything. A comet is a small icy body that orbits the sun. It is a nucleus of frozen gases, rock, and dust, a quiet, dormant object in the cold dark of space. But as a comet approaches the sun in its long elliptical orbit, the warmth of our star causes the ice to sublimate or turn directly from a solid into a gas. This creates a vast, luminous cloud of gas and dust around the nucleus called a coma. The pressure of the solar wind and radiation then pushes this material away from the comet, creating two spectacular tails. The first is a straight bluish ion tail, which is made of electrically charged gas particles and always points directly away from the sun. The second is a curving white or yellowish dust tail, which is made of fine dust particles and follows the comet's orbital path. It's a breathtaking transformation, a quiet, icy body suddenly bursting into a fiery, beautiful display of light. There are two main types of comets, which correspond to the two main cometary reservoirs we have just visited. There are short-period comets, which are believed to originate in the Kuiper belt. These comets have orbits of less than 200 years and tend to be confined to the same plane as the planets. Halley's Comet, a famous short-period comet, is one of these visiting our inner solar system every 75 years or so. Then there are long-period comets, which are believed to originate in the distant spherical Oort cloud. These comets have orbits that can take thousands or even millions of years, and they can come from any direction in the sky, a testament to the spherical nature of their birthplace. These are the ancient wanderers, the true messengers from the dawn of our solar system. A fascinating and lesser-known fact about comets is that they are not just quiet, beautiful wanderers. They are also a key part of our planet's story. It is believed that a significant portion of Earth's water may have been delivered by comets and asteroids during the late heavy bombardment, a period of intense cosmic impacts in the early history of our solar system. These icy messengers crashing into our planet would have helped to fill our oceans and provide the very building blocks for life. It is a powerful and poetic thought. The very water that flows in our rivers and oceans, the very essence of our being, may have come from the far cold edges of our solar system, delivered by these cosmic snowballs. The chemical composition of comets is another source of wonder. They are a pristine ancient sample of the material from which our solar system was formed. By studying comets, we can learn about the conditions of the protoplanetary disk, the swirling cloud of gas and dust from which our sun and planets were born. Comets contain a wide variety of organic molecules, the building blocks of life, and it is possible that they also delivered these to early Earth, a kind of cosmic seeding that helped to kickstart the process of life. It's a profound thought these quiet, icy bodies may be the very genesis of our own existence. The journey of a comet is one of slow, patient decay. Each time a comet passes close to the sun, it loses a little bit of its icy material. Its tail's a beautiful fiery sign of its slow erosion. Eventually, after thousands of passes, the comet will run out of its volatile material and become a quiet rocky husk, an ancient dead world that continues its long, lonely journey through the cosmos. It's a beautiful and sorrowful cycle, a reminder that nothing in the universe is permanent, and that even the most beautiful of cosmic displays is a sign of a slow, patient decay. This raises an interesting question. What happens to the dust and rock that a comet sheds in its journey? These tiny particles continue to orbit the Sun, forming a kind of ghostly stream of debris in the comet's wake. When Earth passes through one of these streams, the particles burn up in our atmosphere, creating a beautiful display of light that we call a meteor shower. The Perseid meteor shower, which we see every August, is a beautiful example of this, created by the dusty debris of the comet Swift-Tuttle. The very light we see in our night sky is a kind of cosmic echo, a quiet, beautiful reminder of a comet's long-ago journey. The truth is, we don't really know for sure what all the debris streams from comets are, and each one is a new and beautiful discovery waiting to be made. As we drift watching the ghostly light of a distant comet, we are left with a feeling of deep humility and wonder. These are not just beautiful fleeting lights in our night sky. They are ancient messengers, silent witnesses to the birth of our solar system, and perhaps even a key part of our own story. They are a testament to the fact that even in the most empty and distant corners of the cosmos, there is still a story to be told, still a connection to our own home. And with the comets now fading behind us, we turn our attention to the final component of our cosmic story, the great rocky remnants of our solar system's past, the asteroids. We have journeyed from the Sun's gentle whisper to the farthest theoretical edge of our solar system and back, encountering planets, moons, and comets along the way. Our final stop before the end of our journey takes us to a place of immense history and quiet, chaotic beauty. We are now in the great dusty chasm between Mars and Jupiter, the home of the asteroid belt. This is not a dense field of flying rocks, as science fiction often portrays it, but a vast empty region where countless asteroids, large and small, drift in a slow, patient, and sometimes chaotic ballet around the Sun. The asteroid belt is a testament to what might have been. It is believed to be the remnants of a protoplanet that never quite formed. In the chaotic early days of our solar system, Jupiter's immense gravitational influence prevented the dust and rock in this region from coalescing into a single large world. Instead, the material was scattered and broken apart, leaving behind a vast collection of cosmic debris. The total mass of the asteroid belt is actually quite small, less than the mass of our Moon. This makes the space between the asteroids immense, a place of quiet solitude, where collisions are rare, but when they do happen, they are catastrophic, reshaping the asteroids and sending fragments hurtling through the cosmos. There are three main classifications of asteroids based on their composition. C-type asteroids, or carbonaceous asteroids, are the most common. They are dark in color and are believed to be the most primitive, containing a high amount of carbon and other organic compounds. S-type asteroids, or siliceous asteroids, are made of stony materials and are the second most common. And M-type asteroids, or metallic asteroids, are made of nickel and iron and are believed to be the remnants of the cores of ancient shattered planetesimals. This incredible diversity in composition is a powerful reminder that the asteroid belt is not a single entity, but a vast, diverse collection of different worlds, each with its own unique story etched into its rocky surface. A fascinating and little-known fact about the asteroid belt is that it is the birthplace of meteorites. When asteroids collide, they can send fragments of rock and metal hurtling toward the inner solar system. Some of these fragments can be captured by Earth's gravity and fall to our surface. A meteorite is a piece of rock or metal from space that has survived the fiery journey through our atmosphere and landed on the ground. By studying these meteorites, scientists can learn about the composition of the asteroids themselves, and in turn, about the building blocks of our solar system. The meteorites in our museums and research labs are not just rocks. They are ancient messengers, tiny pieces of our cosmic past that have survived an incredible journey to tell us their story. The asteroid belt is not just a place of quiet, dusty rocks. It is also the home of the main belt comets, or active asteroids. These are objects that have the orbit of an asteroid, but the beautiful cometary activity of a comet. It is believed that these objects contain water ice beneath their surface, and when a collision or some other event exposes the ice to the sun, it sublimes, creating a beautiful cometary tail. It is a stunning example of the blurry lines between different cosmic objects, a reminder that the universe is not always neatly categorized. The truth is, we don't really know for sure how many of these active asteroids exist, and each new discovery is a testament to the quiet dynamic nature of this seemingly empty region. The gravitational influence of Jupiter is the great sculptor of the asteroid belt. The immense gravity of the gas giant has created gaps in the asteroid belt called Kirkwood gaps. These are regions where there are very few asteroids because the asteroids in those orbits would have been gravitationally pulled into a resonance with Jupiter and then flung out of the belt. It is a beautiful and powerful example of the silent yet constant influence of gravity, a force that both holds our solar system together and creates gaps in its most populated regions. The Kirkwood gaps are a kind of cosmic sound wave, a silent, unmoving testimony to the power of our solar system's king. As we drift through this quiet, dusty realm, we are left with a feeling of deep humility and wonder. The asteroid belt is not just a collection of rocks. It is a repository of our solar system's past, a silent, shattered world that holds the secrets of its formation. It is a testament to the fact that even in the most quiet and seemingly empty corners of the cosmos, there is still a story to be told, still a connection to our own home. And with the asteroids now fading behind us, we prepare to conclude our journey to reflect on the beautiful and intricate tapestry that is our solar system. We have completed our long, slow journey through the cosmic neighborhood, a gentle drift from the sun's burning heart to the theoretical icy edge of our solar system and back. We have witnessed worlds of fire and ice planets, of immense scale and quiet dusty rocks. We have seen the birth of a moon from a cataclysmic collision and the slow patient decay of a comet. We have seen the great quiet symphony of gravity holding it all together and the mysterious unsolved questions that whisper from every corner of the cosmos. Our journey has been a testament to the fact that our solar system is not just a collection of planets, but a beautiful, intricate tapestry woven from the threads of time chaos and cosmic dust. It is a family of worlds, each with its own unique story, but each one connected by a single common parent, our sun. The final overarching theme of our journey is the profound sense of interconnectedness. Nothing in our solar system exists in isolation. The sun's gentle whisper of solar wind shapes the comets and creates the aurorae on Earth. Jupiter's immense gravitational pull sculpts the asteroid belt and protects the inner planets from cosmic debris. The moon's quiet, rhythmic dance stabilizes our planet's tilt and creates the tides in our oceans. Every planet, every moon, every comet, and every asteroid is a piece of a larger living whole. They are all part of a single flowing story, a cosmic ballet that has been playing out for billions of years. To understand one part is to understand a little bit more about all of them. One of the most beautiful and poignant ideas in modern astrophysics is the concept of cosmic recycling. The very atoms that make up our bodies, the carbon in our bones, the oxygen in our blood, the iron that gives our blood its color, were not formed on Earth. They were forged in the fiery hearts of ancient stars that lived and died long before our sun was born. These stars, in their death throes, exploded, scattering these heavy elements throughout the cosmos. Our solar system was formed from this stardust, this beautiful ancient wreckage. We are quite literally made of star stuff. This is not a metaphor. It is a scientific fact. We are a part of the universe, a brief fleeting moment of consciousness in a long, slow process of cosmic recycling. It is a humbling and beautiful thought, a powerful reminder of our place in the grand scheme of things. A fascinating and little-known fact about our solar system is that planets' orbits are not perfectly stable. Over billions of years, the gravitational tugs and pulls between the planets can lead to subtle but significant changes. While our solar system is stable for now, a concept called chaotic systems suggests that over a timescale of billions of years, even the smallest perturbation could cause the orbits of the planets to become unstable. This could eventually lead to a planet being flung out of the solar system, or even crashing into another. This is not a cause for alarm, but a quiet, scientific whisper from the deep future, a reminder that even the most stable-seeming systems in the universe are subject to the long, slow work of chaos and chance. This raises a philosophical question. Is the universe a place of perfect, predictable order? Or is it a place of inherent, beautiful chaos? The truth is, we don't really know for sure, and this quiet, unanswered question is one of the most compelling mysteries in all of science. Our journey has been a testament to the beautiful and profound reality of our universe. It is a place of immense scale and quiet, intricate detail, a place where a single star can govern the fate of 1,000 worlds, and a tiny icy comet can carry the very building blocks of life. It is a place of endless mystery, a place where the more we learn, the more we realize how much we don't know. The universe is a great silent ocean, and we are just beginning to learn how to swim. We are now floating quietly in the blackness, our journey at an end. The planets, moons, and asteroids are all distant points of light, each one a memory of a place we have visited, a story we have heard. We are left with a feeling of deep serenity and quiet wonder. The universe is not a sterile, cold place. It is a place of immense patient life, a place of beautiful rhythmic change. And so we bring our long, slow drift to an end. It has been a pleasure to have you as my companion. We now begin our slow and gentle return, letting the vastness of the cosmos slowly, softly fade. Let the light of the distant stars gently brush past your awareness like a soft wind in a quiet field. The cosmic dust of ancient shattered worlds slowly fades into a soft, comforting darkness. We're not racing back, but simply allowing ourselves to drift, to slowly lose our connection to the planets and the moons, and to regain our connection to this moment, to this room, to this stillness. I'd like to gently ask one last time, where is the place you're staying now? The time in that place at this very moment, how is it flowing? Let the memories of the Sun, Mercury, and Venus, and all the worlds we visited slowly melt away into the quiet darkness behind your eyes. Let them become a soft, warm glow, a memory of a journey that was as much an internal one as it was a physical one. There is no need to hold on to the details. Just let the feeling of it all, the gentle curiosity and the deep wonder, settle softly within you. And now, as you settle in, and the world outside fades to a gentle hum, I want to leave you with one final quiet thought. The universe is a vast and mysterious place, but it is also your home, and within it, there is always room for a gentle breath, for a soft smile, for a quiet moment of peace. So before you drift off completely, let's take a moment to be grateful for the stillness, for the peace, and for the promise of a new day. Thank you for being my companion on this long, slow journey. Sleep well, my friend. Wherever and whenever you are, may your dreams be as vast and as beautiful as the cosmos we just explored. Sweet dreams.